Hello everybody, and welcome back to another Algebra 1 video. Today we will be continuing lesson 5.4 with its extension on special functions. The first of the three special functions we'll be learning today are piecewise functions. A piecewise function is a function defined by two or more equations. As shown here, this is an example of a piecewise function, and you'll see that we have two linear equations, y equals x minus 2, and also y equals 2x plus 1. Each piece of the function applies to a different part of its domain. So you also have two different domains, x is less than or equal to 0, and x is greater than 0. So you're going to use these domains to graph each piece of your piecewise function. Now, piecewise functions are like graphing normal linear functions with just a few extra steps. First, you need to recall some knowledge from the inequality section, and remember your inequality symbols and open and closed circles. For inequality symbols, like less than or equal to or greater than or equal to, you're going to use a closed circle. However, for inequality symbols that are greater than or less than, you're going to have an open circle. So in this case, you're going to plot either a closed or open circle at the y-intercept of your linear equation. As for the domains, we see here that we have x is less than or equal to 0 or x is greater than 0. That tells you what part of your line you are going to graph for the piecewise function. So I'll go ahead and break that down with this example. We see here that both of our linear functions are in y equals mx plus b form. So we can use our y-intercept and our slope to graph our two lines. Let's start by graphing y equals x minus 2. If x is less than or equal to 0. First, you want to look at the sign of your inequality symbol. In this case, it's less than or equal to, so we know that we're going to use a closed circle at the y-intercept, -2. So go ahead and draw your closed point at -2 on your y-axis. And from there, you want to look at your actual domain and also the slope of your linear equation. Your domain is x is less than or equal to 0. This means that you only want to graph the part of your line where x is negative. So in this case, you're going to graph the part of your line that is to the left of your y-intercept. Your slope here is +1. So you're going to rise 1 unit and run 1 unit to the right. However, if you were to do that, you would get points where x is greater than 0. So you want to go ahead and draw points below your y-intercept. The way you would do that for positive slopes are you would go down 1 unit and go 1 unit to the left. Down 1 unit and 1 unit to the left. And that's because you need your points going up towards the right, since your slope is positive. Once you've plotted at least 2 points, you can go ahead and connect them with a line. Now you can do the exact same thing for your other piece of the function, which in this case is y equals 2x plus 1 if x is greater than 0. Again, first look at your inequality symbol. It's greater than, so we know that we're going to use an open circle at our y-intercept of +1. So plot your open circle here at your y-intercept of 1, and then now look at your domain. Its x is greater than 0. So you know that you want to plot the part of your line where x is positive. So in that case, it would be to the right of your y-intercept. Looking at our slope, we have +2, so this would be rise 2, run 1. So since it's positive, you're going to rise 2 units and run 1 unit to the right, and there is your second point. Rise another 2 units and run 1 unit to the right, and there is a third point. Again, you only need a minimum of 2 points, and once you've plotted all your points, go ahead and connect them with a line. and this is how your final piece function would look like. For our first example, we're going to graph this piecewise function, then describe the domain and range. Our piecewise function is y equals negative x minus 4 if x is less than 0, and y equals to x if x is greater than or equal to 0. First thing to note is, again, your linear functions or linear equations are in y equals mx plus b form. I'm going to go ahead and start by graphing y equals negative x minus 4 if x is less than 0. First step you want to do is look at your inequality symbol. It's less than, so we know we're going to use an open circle at our y-intercept of negative 4. So go ahead and graph your open circle at your y-intercept, and from there you want to look at your domain. And this is how you're going to determine which part of your graph you're going to draw. In this case, we have x is less than 0. This means you want to draw the part of your line where x is negative. So that would be to the left of your y-intercept, or where all the x values are negative, as you see here. Now we can go ahead and plot our other points using slope. So again, we want to plot our points to the left of our y-intercept, where x is less than 0. Our slope here is negative 1. This can also be seen as negative 1 over 1. And generally, whenever you have negative slope, in this case negative 1, instead of rising however many units, you want to go down 1 unit and then 1 unit to the right. But if you were to do that, you would get a point where x is greater than 0. So here is how to plot points in negative slope above your y-intercept. You're going to rise 1 unit, but instead of going to the right, you're going to go 1 unit to the left. And so you can plot your point. You can do that a few times until you get a few points. And the reason why you want to go to the left rather than to the right is so that your points are pointing towards the left. And remember that all lines with a negative slope will point up towards the left. So once you've plotted all your points, go ahead and connect them with a line. And now we can move on to the second part of our piecewise function, which is y equals x if x is greater than or equal to 0. Now y equals x doesn't really look like it's in y equals mx plus b form, but this just has a y-intercept of 0. If there's no y-intercept stated like negative 4, then you can automatically know that it's just at 0. So looking at our inequality symbol, we see we have greater than or equal to. This means that we have a closed point at our y-intercept of 0. So if you plot that, it would be right here. And from there, look at your domain. It's x is greater than or equal to 0. So you want to draw your points where x is positive. So that would be to the right of your y-intercept, where your x values are positive. Now from here, we can go ahead and use the slope given in our equation, which is 1, or 1 over 1, to draw our other points. So if our slope is 1 over 1, you want to rise 1 unit and run 1 unit to the right, and you can plot a point there. You can keep doing that until you have a few points. Then connect them with a line. Now we can go into describing the domain and range. Now for all piecewise functions, you're generally going to have a domain of all real numbers. Remember that the domain is the set of all your x values or inputs. So this just means that you can input any real number for your x value and you'll get a corresponding output or y value. For range, you're going to make an inequality, and remember range is the set of all your y values in a function. First thing you want to look for is that both of your lines are pointing in the same direction. So in this case, both of these lines are pointing upward. So you want to look if both of your lines are pointing upward or if they're pointing downward. In the case that one is pointing upward and one is pointing downward, you're actually going to need to write two different inequalities so that you account for the ranges of both of the functions. In this case, since both of them are counting upward, we only need to write one inequality. I recommend that if they're pointing upward, you look for the bottommost point. In this case, that would be an open circle at -4. So since it's an open circle, you're going to have y, and then either greater than or less than -4. The way you determine your inequality symbol is by looking at the direction your lines are pointing in. Since they're pointing up, I'm going to use a greater than symbol, so your final range would be y is greater than -4. For this example, our piecewise function looks a little bit different since we see here we have three different linear equations and also our domains aren't zero. I'm going to start off by graphing the first linear equation, which is y equals to -x plus 2 if x is less than or equal to -2. Now what I recommend when your domain isn't zero is that you first focus on just graphing your linear equation, and from there you can go ahead and erase whichever part of your graph that doesn't fall under your domain. So looking at our inequality symbol, it's less than or equal to, so I know it's going to be a closed point at our y-intercept of +2. So here is our y-intercept, and from there we can graph a few points using slope. We know that our slope is -1/1, and looking at our domain, it's x is less than or equal to -2, so we know that we want some points that are to the left of our y-intercept. So I'm going to go up 1 unit and then 1 unit to the left. Here is a second point. Go up 1 unit to the left, a third point, and keeping in mind our domain of x is less than or equal to -2, I want to graph a few points farther from -2 so that I can draw a line. So I'm going to go up 1 unit and 1 unit to the left, and then I'll do that one more time, and there is our last point. Then looking at all the points that we graphed and then looking at our domain, remember our domain is x is less than or equal to -2, so we only want points where x is less than or equal to -2, so it would be these 3 points right here. So what you want to do is you want to erase these 2 points that you originally graphed, and from there you can go ahead and connect your 3 points, and here is your first linear equation. Now we can move on to y equals 5 if -2 is less than x is less than 1. When you have a linear equation where y just equals to a value like 5, this is actually a horizontal line. So we know we're going to draw a horizontal line through 5. But looking at our domain, we see that it's -2 is less than x is less than 1. So we only want to draw our line where these values are true. Looking at our inequality symbols, both are less than, so we know we're going to use open circles at -2. So -2 would be right here, so I would draw an open circle there, and then at +1. And here's +1, so there's your other open circle, and then you can go ahead and connect those 2 dots. So this would be representative of y equals 5 when -2 is less than x is less than 1. And now finally, for our last linear equation, we have y equals 3x if x is greater than or equal to 1. First, I'm going to go ahead and graph my linear equation. Since there's no y-intercept stated, we know that it's going to be 0. So looking at our inequality symbol, it's greater than or equal to, so plot a closed circle at 0. From there, we can go ahead and use slope. So I'm going to go up 3 units over 1 unit to the right, then up 3 units and over 1 unit to the right. And looking here, it's x is greater than or equal to 1, so you want to make sure you're plotting all your points to the right of your y-intercept. And now looking at our domain, again it's x is greater than or equal to 1, and looking at our points, we see here that these are the 2 points where x is greater than or equal to 1, so you want to get rid of your point at 0, 0 here, and then you can go ahead and connect those 2 points. And here is your final piecewise function graphed. For the domain and range of this piecewise function, remember that domain is always going to be all real numbers. As for range, you want to look at the direction of your lines. So between the 2 lines that do have a slope, they're both pointing upwards. Between those 2 lines, the lowest point would be at 3 on the y-axis. Remember that for range, you're going to write an inequality for y. So looking at the lowest point, it is at 3 and it is a closed point. So you know it's going to be either greater than or equal to or less than or equal to. The horizontal line that we graphed is above 3 on the y-axis, and both lines are pointing upward, so you know it's going to be greater than or equal to positive 3. And that would be your final range. For this example, we're going to write the piecewise function for the graph rather than actually graphing the piecewise function. So the 2 things you need to find are first the linear equation for the line and also the domain. I'll start with this line right here. First, I'm going to write the linear equation. Remember, it should be in y equals mx plus b form. So you want to find your y-intercept and also your slope. So our y-intercept is at -1, so I'll replace b with -1. And for your slope, you can go ahead and count the rise over run between the 2 solid points. So I see a solid point right here, see another solid point right here, and then of course we have our solid point at our y-intercept. So from between these solid points, you can go ahead and count the rise over run. You're rising 2 units, running 1 unit to the right, rising 2 units, and running 1 unit to the right, so you know that your slope is 2 over 1, or just 2. So your final linear equation would be y equals to 2x minus 1. Now that you've found the equation for your line, we can go ahead and find the domain. Remember, the domain is going to be an inequality for all your x values in the function. So first look at your starting point of your function, and you see that it is a closed circle, so it's going to be x is either greater than or equal to or less than or equal to then a value. Looking at our starting point, it is at 0 on the x-axis, and from there it continues to the right, where x is greater than or equal to 0. So your final domain is going to be x is greater than or equal to 0, and then for this line, it's going to be y equals 2x minus 1 if x is greater than or equal to 0. Now we can write the equation and domain for the other piece of our function, which is this line right here. First, I'm going to write the linear function. Remember, it's going to be in y equals mx plus b form. First, you want to find the y-intercept. Here, our y-intercept is at positive 3, so I know our b value will be plus 3. And as for m, which is slope, you want to find the rise over run between 2 or more solid points. So go ahead and find the solid points on your line first. Here are the 4 that I found, and from there you can go ahead and find the rise over run over between any 2 points. So here I have rising 1 unit over 1 unit to the right, rise 1 unit, run 1 unit to the right, and that pattern follows until we hit our y-intercept. So we know our slope is 1 over 1, or just 1. So you can put y equals to 1x plus 3. You can also leave out the 1 and just put y equals x plus 3. Now that we've found the equation, let's go ahead and find the domain. So first, look at your starting point. Remember that domain is going to be an inequality for all the x values in your function. So it's going to be x. This is an open point for your starting point, so it's going to be greater than or less than. And then your starting point is here at 0 on the x-axis. And from there, it continues to the left of 0 where your x's are negative. So we know it's going to be x is less than 0. So your final linear equation for this line is y equals x plus 3 if x is less than 0. Now that you've found the equations and domain for both of your lines, go ahead and set them up in a piecewise function. So it's going to be y equals to this bracket, and then just go ahead and write your linear equations and their domains. And here is your final piecewise function. That is it for today's video. I will be covering absolute value functions and step functions in the next video. Usually I do have an additional practice assignment, but that will be linked in the description box of my next video once we've covered all 3 special functions. If you have any questions about the problems that I teach in these videos, please feel free to reach out to me at kaelin.david24@gmail.com. I'm always open for questions, and as always, all information regarding tutoring and lesson requests are down below in the description box. Thank you so much for watching. If you enjoy the content, please feel free to subscribe and like the video, and I hope to see you in the next video.